Hello, my name is Ted Ward and I'm from the Autodesk Windsor, Ontario office, and I'm a technical sales specialist for PowerMill. This demonstration is to help you get the most out of your mill turn capable 5-axis machine. The part you see here in question is made up of cylindrical surfaces as well as some additional features around the outside of the part, such as this boss and also these two tabs that you see on the outside. This kind of part would require some specialised turning strategies along with some additional milling operations. Let's go ahead and start defining our stock. In this case, we're going to pick cylinder out of our list of options, and we're going to ask PowerMill to calculate our initial limits of the part, looking at the X, Y, Z parameters there. And from there we can go ahead and override any of these numbers here. So the diameter, I'm going to increase that to say 182 millimeters. And then probably what I've already done is define some kind of operation to remove the center of this part already. So in this case, I'm going to define the inner diameter as 50 millimeters. Then I'm going to view from the front and just go and add some additional stock to the top of the part. So I'm going to override this max Z parameter to 335, so a couple of extra 2 millimeters of stock there, and that's the stock that will be taken off in our initial starting face roughing and finishing toolpaths. Okay, so once we've added the stock, what I now need to consider is how I'm actually holding this stock combined with the part. So to help me do this, I'm going to utilize on my custom ribbon interface here a little vice utility that if I open this up, what it does is give me a list of general sort of work holding systems ranging from various different vice, and then down the bottom, the one that I'm interested in, 4-jaw 10-inch turning chuck. From here it's a case of just telling PowerMill where to connect to the actual model. So in this case I'm just going to specify connect this to the stock that I've just previously applied, and then I'm going to click import. What this then does is build a particular file, assembling all of the particular components of the vice. And again, that could be very useful in our milling or turning operations by giving us some nice sort of collision checking capabilities. So once I've got the turning chuck and the model, what I would now need to do would be to apply my, pick my coordinate system. Now PowerMill has a wide variety of different coordinate system sort of routines here. Now obviously because of the shape of the part, I'm going to go for the one that defines one from a revolved surface, and then just by highlighting on the model itself in PowerMill gives me the option to pick various sort of cylindrical components of the model. I'm going to pick this extension surface at the bottom. Then it's a simple case of picking what side I would like my coordinate system. So I'm going to pick that coordinate system there. I'm just going to go over to my Explorer tree here and just rename this to be part. That would be, let's say, my output coordinate system. And from there what we can do is then introduce the machine tool in question. So let's activate my machine tool and let's explain a bit more about this mill turn capable 5-axis machine. Now if I go and open my simulation parameters here, I'm just going to open up the machine tool positioning form. And this gives me the list of sort of axes pertaining to this particular model, the x-axis, the y-axis, the z-axis, and more importantly here what we've got is our unlimited sort of c-axis turning capability here. So what this will allow me to do is obviously machine down the traditional z-axis of this milling machine, or even, as you might see later on, I'm just going to rotate my b-axis round and I may then be machining, let's say, along the part in this direction, but once again the C-axis will be rotating as you see there. Okay, I'm just going to home the machine and take that back, just turn the machine off. Now there's a couple of viewing options that PowerMill has to help me program along the way. Couple of options here, so as if I was looking at the standard sort of milling setup as you saw a minute ago where the part was straight up the traditional milling axis, or then we could just switch that to our turning axis. So if I just take a view from the side, that would be our normal sort of traditional turning configuration. Okay, so let me just go back now and we're just going to turn off via my levels. Just going to undraw my vise that I just added earlier. Switch back to my milling view, and then we can look at how we go about defining our turning features to produce obviously our turning toolpaths. Now, because of time constraints, I'm not going to be machining the whole of the model with these turning toolpaths. I'm just going to take a selection just to show you PowerMill's workflow, just to show you how to how we go about creating, let's say, the face feature, followed by a turning feature on the outside along with a rest roughing style toolpath, and then also how we would go about defining some kind of groove features to get these more sort of intricate areas around the outside. Just turn off my tools for now, shut off my levels here. Okay, so I need to create my first feature, and that's going to be my face feature. So I'm going to go to my feature group tab on my interface here. I'm going to say create a new feature group, and then in that feature group I'm going to decide what kind of features I like to create. Now, this toolbar contains all of your 2D features as well as the ones I'm more interested in today, which would be your turning features, as well as things like the editing of the features, etc, etc. So let's define our initial turning face feature. Now it's asking for the Z position here, so I'm going to utilize the model that I have obviously in the PowerMill interface there. I'm going to lock onto this top face. That would be my final face Z value. And then just by switching off my model, what I can then do is then sort of interactively drag the dimensions of this face feature, and I can lock on to the outside and the inside diameter of this block. Let's call this face just for reference so I remember in the future, and then hit apply. Once I accept, there's my feature. Let's just turn our model back on, and then from there I can go ahead and then start creating my first toolpath. So I'm going to go straight to the toolpath tab, create a toolpath. What this will do is open up PowerMill's wide sort of variety of strategies that are available for me depending on the kind of machining process that I need to achieve here. In this case, let's look at these. We're just going to look at a selection of these. Now again, I'm not going to machine the whole part just because I haven't got enough time here, but I'm going to show you how to create these features and toolpath, just to show, like I said, the PowerMill sort of mill turn workflow here. Let's go to face roughing. Now I've already created the feature for that. So if we open up the form, let's give it a name. The feature group that I would like PowerMill to look at. So there's my feature group that I just created, and then this style of toolpath only picks the face features, which makes it easier for me to select. So the tool I'm creating, just to sort of mention a few things here, PowerMill's got a sort of wide variety of different tools that we see here. Your milling, traditional milling style tools, and then also your gives you the ability obviously to create your turning, your grooving tools, etc. Like I said, I have a predefined list of tools that I'm going to be working with. So I'm just going to pick my 80-degree diamond there just to do the facing operation on the top. And then it's just a case of giving the toolpath a tolerance as you would in any normal toolpath form within PowerMill. The thickness I'm going to leave on, and then the depth of cut that you would like. From there it's just a case of calculating the toolpath, and then that would be your face roughing toolpath, and then straight away we can go and pick a face finishing toolpath. Thickness left on, the previous thickness, that was the 0.1 that I left on from the face roughing, the number of cuts that I would like, and then hit calculate. So quickly and simply we've just faced the part with the rough and the finish. Let's just zoom in. I'm just going to turn the block off here. Let's look in a bit more detail at the toolpath. Now if I wanted to manipulate those leads and links, I wouldn't necessarily have to go and calculate the toolpath again. All I would need to do is go to my toolpath edit tab, go to my toolpath leads and links, and then maybe update the toolpath to have maybe a longer lead in if that was required. PowerMill's leads and links are independent of the toolpath calculation itself. So like I said, you don't have to recalculate the toolpath each time you want to make a simple edit or an update to a lead and link. Okay, let's bring the model back on. Let's just quickly name that toolpath I created. Okay, now I'm going to switch to my sort of traditional turn-in view. Now what I'm looking at now is, what I want to do is really just create my initial sort of turn-in toolpath here. And this is where I'm going to introduce, purposely of course, a collision just to show the capabilities of PowerMill. Now what I'm going to be doing is trying to sort of create a turn roughing profile toolpath coming down in this sort of direction here. Now let's just deactivate that toolpath. Now the first thing I would need to do is create my what we call our spun profile. Now this isn't just going to be a simple sort of section. It has to obviously take into consideration, once the part is revolved, all of the high points of the model, including the tabs. Oops, let's just rotate the part this way, and even this boss at the top. So obviously it's very important that it's created in that manner. So first of all, what I'm going to do is just quickly select the surfaces that I'd like to include in the turn profile. I'm going to go up to my pattern toolbar. I'm going to say create me a pattern, and then from there I'm going to enter into the sub menu called the curve editor there, where I can utilize creation tools, editing tools, etc, etc. So the one that I would like to create is actually a curve, and that curve is called spun profile. Now like I said, I've already created already selected the surfaces that I need to include in my profile, and then it's just a case of picking the axis of rotation, which would be around my Z axis. Let's hit create. PowerMill goes away and does all its spun sort of calculations there, creating me my profile. I'm just going to accept out of that for now and turn off the model so we can see exactly what's going on. But what that's doing is giving me the outside of the part, the highest points, the spun profile, and also the inside points. And it's from this curve that we then go and define and create our features. So I'm going to deactivate that pattern and just sort of draw it when it's not selected, because I'm now going to utilize this particular curve sitting in the background to help me visualize the kind of features that I want to create there. Okay, so I'm going to go back to my feature group. I'm going to go to the feature editor, and like I said, I want to create the outside profile. I'm going to be doing a normal turn roughing style toolpath and also a rest roughing toolpath, but what I'm going to do is introduce maybe the wrong way of machining this, the wrong orientation on the machine, and then go and show you how I can quickly number one, see the collision and then modify it afterwards. Okay, just going to turn this feature off here, and then I'm going to say I would like to create a profile. So a profile turning feature. Let's give it a name, outside profile. Enter into this curve editing form again, and this time I'm going to go and pick what we call a composite curve. So I need to define my start points of where I want the curve obviously to start, and then the end point right there, and then pretty much just chain between those two start and end points. I'm going to record that, that's correct, hit the green check, and once I accept that, that's going to spin that profile around the Z axis to give me my feature with which for me to to create my first toolpath. So let's accept that. We'll turn on our features. I'm going to turn on my part again. Actually, let's just put it in this orientation, and then go back to the toolpath form, and we're going to pick turn roughing. Now, like I said, I purposely want to sort of set this up from the wrong orientation in a way. First of all, let's introduce the thickness we want to leave on, so obviously consistent parameters through all our toolpath form. We can pick different styles of different cycles, different styles. The one that I would like just would be like a one-way turn-in cycle here. We go to the feature group, select the feature that we'd like to particularly look at, the tool, And then I'm just going to go and change this from the traditional sort of turning direction. Change a couple of parameters and I'll show you what I mean in a minute. But there's my, let's adjust my step down and then calculate. Okay. So a couple of different options here. Let's just rotate the part, just quickly have a look at these. I'm just going to go back into the toolpath form. Now there's various different options for when dealing with these sort of undercuts that we see here, especially when coming in from this direction as you see there. If I just recycle, let's look at how PowerMill would deal with these undercuts. Now you can just say no checking, obviously that would not be good, but that's going to show you the full extent of the toolpath. We could then say, make PowerMill aware of the tool profile itself. But once again, I probably wouldn't want this condition. So I'm going to change that to one I want here. I'm just going to say remove all undercuts, and you'll see any sort of undercuts it detects, it's just going to remove to give me the toolpath like that. Okay, let's just call this profile rough. Now at this point we're just going to say simulate from start. We're going to activate the machine tool. Let's draw the tool. Okay, let's turn these features off just so we can have a bit of a clearer picture of what's going on. Let's turn our vice back on. Oops, let's go to the levels. There we go, make it a bit more realistic there. Okay, so once again, simulate from start. Now I'm going to open up the display issues form here. By doing that, PowerMill just going to go through some initial checking, just making sure it's aware of the spun vice and various other different components of the machine. Now we're going to say here, check the tool and holder and also check the machine, and then we're going to ask PowerMill if it detects a collision, just say always pause on issues. We're going to slow the speed down and then hit play. Now obviously I set this up, have a bit of a problem here, but what's going to happen here is obviously due to the orientation that I'm applying here, let's just turn this off here. Now we've got to, that's obviously not going to be the best direction to, turn this part. So PowerMill then gives me obviously, feedback of exactly what is going on with that toolpath. So not only do you need to create the toolpaths, you need to make sure they're safe at the machine as well. So utilising PowerMill's simulation there to give me obviously instant feedback of anything that's out of place, let's say. Okay. So I'm going to turn this off for now. We're going to turn off the machine tool. We're going to go back into the settings of the toolpath and then switch this more to the traditional direction where we'll be moving obviously down the part. And this would obviously then have the, our mill turn capable 5-axis machine. You would obviously see your, maybe your elevation axis, your B or your A tilted over at 90 degrees as I showed earlier. But let's recycle that toolpath. Let's go back, turn these settings off that I added earlier, and then we'll hit calculate. Okay, we're going to bring the tool back on, simulate from start, bring the machine back, just quickly rotate that into position. So now your C axis is going to be spinning while the part is travelling down the, the traditional sort of turn-in sort of Z axis. And again, then you're not going to get a violation. Again, if we just simulate this, I suppose. Let's show. All right, so that's going to be a much better orientation with which to, turn this profile. Now, obviously, that's going to be leaving stock on. So the second toolpath that I'd like to focus on would be just to sort of go back and machine, not necessarily these areas, because that's going to be more of a specialised grooving toolpath that we're going to get into in a minute. But just this little area here. So I'm going to turn that toolpath off. I'm going to turn the machine off. Let's just look back from this direction. And then we're going to go and choose another turn roughing toolpath, but this time I'm just going to let PowerMill know that there's going to be, I'm going to override the stock parameters that I've already got just by using a simple pattern, and I'm going to show you how to create that. To help me do this, I'm going to just turn on that initial roughing toolpath that I created. This is going to help me just quickly figure out exactly where that stock would be left over. So once again, I'm going to go into my pattern finishing toolpath, my curve editor, should I say, and then we're going to go and pick a single line, and utilising the toolpath that I've already got created, I'm just going to define some wireframe here to show my new sort of stock profile in this area. Let's undraw that toolpath. Now obviously the tool that we used last time wasn't sufficient for this area, so I'm going to go and change that to a rounds in insert style toolpath. And then we should be just a case of, let's just adjust our step down and then hit calculate. So from there what it's done is look at our new stock curve instead of the absolute sort of boundaries of our stock from earlier. Okay, so let's just name that correctly as well. Let's profile rest. And then we're going to move on to looking at how we would go about doing this more, sort of feature that's really going to have to be attacked from sort of, more, number one, a different tool, but from a different direction here as well. Now that wouldn't be your traditional turn-in style toolpath. What we'd have to go ahead and create is first of all a groove feature, and then the toolpath pertaining to that sort of groove style. So let's deactivate our rest toolpath here. Now again, I'm going to go and turn off my vice here, turn off the features that I've got. I can deactivate this particular pattern. I don't need that anymore for this one. And then we're going to go ahead now and create another feature. So we're going to go to our feature group, go to the feature editor. Now what I will be doing is once again looking at the toolpath I've just created to see exactly where this kind of toolpath will need to be cut in. So once again I'm going to go to my, this time it's going to be a different style, a groove. So we're just going to call this double groove. And then utilise once again my composite curve tool. I'm just going to turn the part off here. And then we're going to define our start point somewhere there, and our end point up to here. Click between the two. And then once I'm happy with that, I can click accept. Double groove, that's the name, yeah. So there's my feature. Once I accept out, that's going to create my feature revolved around my Z again. Like that. So there's my feature. Okay, so from there what I can do, I could just simply go and say machine from this particular menu here. This time I'm going to create my groove roughly. Now I'm not going to go ahead and create all the the finishing toolpaths as well. I just want to really just show you the flow of moving from the setup into the turning toolpaths, and then finally what I'm going to do is just take the list of pre-created toolpaths I've already got, update the stock model, and that's then going to drive subsequent milling operations to help me keep moving obviously in the direction of the completion of the part. So groove roughing. Now once again in this particular case I'm going to introduce another collision just again so I can show you in a different sort of method. Instead of the machine colliding, I'm going to show you let's say a holder collide. So first of all I've got a couple of tools here. The grooving tool, which is quite short in this case. Let's turn off my profile rough toolpath. Now this is obviously a specific grooving style toolpath here. Now again, some different parameters that I'll show you in a minute, but depth of cut, how much stock I'm leaving on, again sort of just your normal generic parameters. Let's put the model on and then let's hit calculate. Okay, so if I just sort of go ahead and do a quick simulation, let's just call this groove rough. Let's close the form down quickly. Say simulate from start. We're going to turn the tool on and we can look at exactly how this is going to work. Now in this particular case I might want to update. I might probably want to see, you can see the collision there. I'll show you those collision detection options in a minute. But first of all I'm going to go and switch the strategy. Now this time my option, I don't want to go depth first. Well, I do actually want to go depth first, but I want to plunge in the very center of the feature first of all, and then make my way out from there. Much better sort of style of toolpath for this particular application. So let's say plunge center first, and we'll hit calculate. So we've quickly updated the style. Just quickly simulate that. So what it's going to do is enter into the center of the feature and then move out from there. So obviously I've used the short tool for a reason. I'm going to say simulate from start. I'm going to open up my display issues again. I would like to tell PowerMill to check for collisions, check the tool and holder in this case. We're going to say always pause on issues, and we're going to go ahead and simulate that now. PowerMill just does some quick collision check-in setup in the background, just to make itself aware of the different components. But right there, you see the collision between the model and holder. Again, this is going to give me instant feedback. If I carry on playing through that, PowerMill is going to list off. If I have that set to just pause on the first type, we should be able to just play through from now. And then PowerMill lists all of the the collisions that it deems to to have found. So it's going to allow me to make a more of an informative decision as to the the style of tool that I require, and if I need to change it, then I will. So I'm just going to hit clear for now, turn that off. That's not needed anymore, and we can go back to the toolpath, recycle, quickly change that to the longer variety, and let's just use him. I'm just going to say Control T just to show you that obviously we're then going to be safer, because obviously this tool now has more clearance. So some good sort of machine and shank or holder collision checking options. Very important to obviously deliver safe toolpaths to your machine. So there's your, there's your face features. There's your couple of different styles of roughing and remachining, as well as your very specific sort of grooving style toolpaths. Let's just go ahead and create one sort of finishing profile, and then we'll look at putting all these together and see how we can drive sort of subsequent milling operations. Okay, so in this case now then let's just deactivate this particular tool. Let's go up to our toolpath and we'll just create maybe a turn finishing. Now all of these follow the same sort of workflow. You create the feature using the profiles, and then pretty much then that's just spun around the Z-axis there. Turn finishing. Now in this case what we'll do is use, let's go and pick let's go to our turning tools. Let's pick the 35 degree diamond. And then in this case, let's go ahead and we'll pick the features. The one that I'd like to obviously get PowerMill to look at, the outside profile, and then we'll hit calculate. Let's just check all of my settings here. So we're now going to 0, the previous thickness, the number of cuts that I require, the specific cycle, I'm happy with turn still, and then we're going to hit calculate. Now, it looks like I've already got some limits already applied, and actually it was the stock left over from the previous toolpath. Let's just turn that off and calculate again. Now obviously it's going to look at the whole of the profile here. So in this case, I've got some other operations finished in these areas. So what I'm going to do now is just recycle and then just go to my limit tab, and then we're just going to lock on, we're going to say the minimum Z, and then we're just going to pick maybe somewhere over here. So we're interactively picking this area and then calculate. So that's going to easily just trim off my toolpath to the area that I need. I'm just going to then quickly go in, turn off my features. Now that lead and link isn't something I'd really probably want. I may want to give that a bit more clearance. So once again, I can go to my toolpath editing, go to my connections, and then we're going to go, that's my lead in. So let's just go and adjust that angle to maybe 20 degrees. Maybe a bit too much. Let's just say 10, and then let's just maybe increase the length to 4 millimeters. And again, once again, quickly and easily updating a toolpath without having to recalculate. So there's there's the workflow in PowerMill. There's a selection of sort of turn-in toolpaths. I've just obviously done the groove. Now there's other ones like inside bore, inside groove, that kind of thing. Everything you would need to machine this part. What we're going to do now is really just fast forward now to get into our stock model. So I'm going to take the series of toolpaths that I've already made, apply that to my stock model, and then show you how that can drive sort of subsequent 5-axis positional milling operations, to obviously go ahead and complete the part once you've done all your specialized turning. So I already have a stock model created. So I'm going to simply grab all of these tool paths, the ones I'd already created. I'm going to say add to my stock model. We're going to go ahead and then say calculate that stock model. So one by one, that's going to go and add all of these, really just sort of building up my my nice stock routine to, again, what I'm then going to do is then show you how to quickly make a roughing toolpath from the top, and then show you a couple of other toolpaths I had created there. But the whole purpose of this is to obviously then drive those downstream milling operations. So going from turning through to 3+2 5-axis machining at the end. Right, so there's the last one that it's adding to the stock model. My stock model should appear like so. That's okay for now. Okay, so how do I then utilize that stock model? Let's just turn that off for now. Let's just minimize this. Now all I need to do, I've got a couple of toolpaths already created. Now my rough toolpath here. Now all I need to do, this is just your normal sort of traditional milling style. Now I've obviously created or pre-created a work plane to position the part in the direction that I'd like to cut. So in this case, I'd probably want to mill from the top and then rotate and mill from the bottom. Once again, I'm just going to turn my levels on so I can see the vise. And again, there's the stock model. And all I need to now do is make PowerMill aware of that new stock model. So let's just go to the rest tab, and we can quickly and simply, transfer that data to now the milling operations just by picking stock and then calculate. Now I have a boundary defined. I'm just sort of localizing it in a certain area. And then once that toolpath's calculated, it's just a simple case of updating the stock model, rotating the part again, and machining from the underside. Now I'm only going to show you one creation or one toolpath creation for this particular process. So there's our stock. Now look, again, I've just, let me just go and tidy up my toolpath here. Just going to turn the stock off. So there's obviously the toolpath that's just effectively picked up on the remaining stock. And again, that's been driven by the previous turn-in toolpaths. So I'm just going to step out of that form. I'm going to go to my toolpath editing. Just select the bits of toolpath that I may not want, and then go and get rid of them. So you've got a lot of fine-tuning elements, adjusting leads and links, toolpath editing, etc. So that's driven that particular roughing toolpath. And then the final thing I'll finish up with is just a couple of toolpaths that I'd already pre-created to machine this boss feature. In particular, I just went and created a positional 3+2 toolpath, a corner finishing toolpath, and then one that I'd actually then simply converted into a 5-axis style to avoid maybe any collisions you might have with the shank and the holder. Let's just go and quickly show those settings. Do a quick simulation. So the settings here, I just said, give that tool a particular lean of 5 degrees. Now again, you've got a wide variety of different sort of 5-axis options you can append to your, your turning toolpaths that you've already created. So a lean of 5 degrees. Let's once again bring back the machine. Say simulate from start. Let's rotate that into the correct orientation. Once again, we're going to bring open up the machine tool positioning form so we can see exactly what the machine is doing. We'll just then slow down our feed rates, and then we should be able to just say play. So just showing a nice combination of turning toolpaths, some roughing and remachining toolpaths driven by that particular stock model, and then any kind of finishing toolpaths that you'd like to create. So again, just to show the nice flow of PowerMill for machining these sort of mill turn traditional sort of parts. Okay, so that concludes the end of the demonstration. I hope you've learned a bit about PowerMill's mill turn capabilities with me, showing you the flow. Like I said, moving from the turn-in to subsequent milling operations, and then through to any sort of more specialised 5-axis toolpath. So I hope that's been of some use. If you would like to have any further information, then please contact your local Autodesk office. Thank you.